Hi, in this video we will learn what is the column space of a matrix. So far we have learned all about the subspaces of Rn. Now we are going to assign different subspaces to any given matrix. One of these is called column subspace. Let's see what is the definition. The definition is straightforward and we start for any matrix. Let A be an m by n matrix. And the column space of A, we have a notation for that denoted by COL of A is the subspace of our M spanned by the columns of A. In other words, if the matrix A has column 1, column 2, how many columns we have? N of them. And each one of these columns are going to have M components. So C1, C2 up to Cn are in Rm. Then we can put these vectors together and find the span of that. So span of C1 up to Cn, which we know by a general fact, the span of any set of vectors is a subspace. Here this is going to be a subspace of Rm, and we define the column space of A to be this subspace. Just columns, what kind of space the columns of a matrix generate. Okay, so let's see at least in some examples what is going on here. Okay, so we have a matrix A. We want to determine if the given vectors are in the column of A or not, column space of A. Okay, so this matrix, this vector being in the column is the same thing as checking that is this guy in span of the columns. Yes. But this is, we already know how to find out answer for this question. What we do, we put these vectors in the column of an augmented matrix, and as you can see, this would generate the matrix itself and then augment it to negative 3, 2, 1. So the question is this system or the system related to the augmented matrix consistent? Does it have a solution or not? Well, we know how to find out that. You just try to solve it. Here we can use Gauss elimination. Here I should get rid of this R3 minus 3R1, and that will give us 0, 5, and this will be a negative 9 plus that. This is 10, and while the rest stays the same. Now I want to get rid of this guy, so row 2 times 5 subtracted from row 3. This will give us 0, 0, 0, 0, 1, 2, 1, and negative 2, negative 3. And well, you see, this is now row echelon form, and it is consistent. So that means that consistent, and as a result, well, this guy, yes, it is in the column of the matrix A. So the vector is in call of A. How about this one? Well, we already know what to do, so you just do 1, 0, 3, negative 2, 1, 1, and negative 3. Oh, I'm going to put this guy here, 0, 1, 2. We do the same operation, R3 minus 3, R1, and we get 0, 5, and then 2. The rest stays the same. And then when we do row 3 minus 5, row 2, what we get is this is 0, this is 0, but the right hand side of this guy is going to be negative 3. So 1, negative 2, 0, 1, 0, 1. So this is row echelon form, and as you can see, it is inconsistent. It means that no, this vector is not in the column space of that matrix. Well, actually, in general, we can describe this column space. So describe call of A for this matrix. So what is column space of this matrix? Well, we are looking for x, y, z's, which are in the column space of A, or in other words, if you put that here, you get consistent. Let's see when this happens. So we just do the same steps. X, y, z. We want to get rid of this, so R3 minus 3 row 1. This will give us 0, 5, and the operation we did here is z minus 3x. The rest stays the same. And then we do one more. We get rid of this, R3 minus 5 row 2. And that gives us 0, 0. And here's z minus 3x minus 5y. And this will give us 0, 1, y, 1, and negative 2x. As you can see, this is a row echelon form. And well, to be consistent, the system to be consistent, we have to make sure that the row which is 0 on the left hand side must be 0 on the right hand side. So it will be x minus 3, z minus 3x minus 5y needs to be equal to 0. And as you can see, this is a plane. So column of A is all vectors in R3 such that their components satisfy this guy, this equation, and that is of the plane, basically minus 3x minus 5y plus z equals to 0. Well, you can do all these works. Let me just finish the video by just wrapping up how to check if a vector B is in a column of A. Well, this is what we saw, and it was clear that check if A, B is consistent, or the system related to this augmented matrix is consistent. If it is consistent, yes, then the B is in the column. If it is not, B is not in the column. Okay. So this is one of the three subspaces we are going to assign to matrices. column space. The rest are coming